Back with another exam walkthrough. We've got 2024 October, question number 6, and we've got question number 17. So we've got both of these questions. I want you to pause the video, do it yourself, and then you can watch me solve it. For the MS and the ER, you can go to the end of the video. So this question says that an electron has a kinetic energy of 3.5 times 10 to the raised power of minus 28 joules. Which of the following gives the momentum of the electron in kg meter per second? So we know the formula of kinetic energy is half mv square, but it can also be p square by 2m. So I'm going to quickly show how we derive this as well. So we're going to take this original equation and we're going to multiply both sides by m. So we're going to have half m square v square. So I multiplied this both sides by m. We know that momentum is equals to mass times velocity. So p square is going to be equals to m square times v square. So we're going to have the kinetic energy times the mass, half times p square. And then I can make the kinetic energy the subject. So I'm going to get p square by 2m. So now what I can do is I can make p the subject. So momentum is equals to the kinetic energy times 2m and then square root. Okay, here we have the electron. So m should be the mass of the electron. And then 2 times the kinetic energy, and that should be d. We have 2 times the mass of electron times 3.5 times 10 to the raised power of minus 28. So now question number 17, it says the photograph shows a toy aeroplane suspended from a fixed point by a thread. The toy aeroplane has a motor that turns a propeller. As the propeller rotates, it sweeps out a circle of radius 4.1 centimeters. The propeller pushes air backwards at a speed of 2.4 meter per second. Show that the propeller pushes a mass of air of about 3 times 10 to the raised power of minus 3 kg backward in a time of 0.2 seconds. And they've given us the density of air. So the propeller moves in a circle which has a radius of 4.1 centimeter. And it sweeps back, or pushes back 2.4 meters every second. Okay, so it forms a cylinder. So we have this 4.1 centimeter here, and this is going to be 2.4 meters every second. So this is happening every second. And as the propeller pushes the air backwards, the air, by Newton's third law, is going to push the aeroplane forward. That's how it's going to move. So we can connect this to Newton's third law as well. Okay, anyways, now what we can do is we can find this volume. So the volume of this cylinder is going to be pi r square h. Okay, but remember, we also have to take into consideration the time as well. So we're going to have pi 4.1 times 10 to the raised power of minus 2 square times 2.4, and we're going to get the value as, so that's going to be 0.01267 meter cube every second. Remember that. That's very important. Okay, now we have this. So now we can use density is equals to mass over volume. Okay, and I can do 1.3 kg meter minus 3 times 0.01267 meter cube divided by per second. Okay. Now what we can do is we can multiply both of these. This will cancel out. And what we're going to end up with is 0.01647 kg every second. So this is basically the mass of air that's pushed backward every second. But we don't want for every second, we want for every 0.2 second, or we want it for 0.2 seconds. So I'm gonna multiply this by 0.2 seconds. Just going to cancel out, times 0.2, that's going to give me 3.295 times 10 to the raised power of minus 3 kg. And that's approximately 3.3 times 10 to the raised power of minus 3 kg. So now we're going to be doing the last two parts of this question. And it says determine the momentum of the air pushed backwards by the propeller in a time of 0.2 seconds. So momentum is equals to mass times the velocity. Now the mass of the air that's pushed backwards is 3.29 times 10 to the raised power of minus 3. And the velocity at which it is pushed backwards is going to be 2.4 meter per second. And that's given to us in the question. It tells us as the propeller rotates, it sweeps out a circle of so and so, and the propeller pushes the air backwards at a speed of 2.4 meter per second. And I'm going to multiply this, and I'm going to get the answer as, I'm going to get a 7.91 times 10 to the raised power of minus 3 kg meter per second. And now in the next part it says, determine the forward force exerted on the aeroplane by the action of the propeller. So the force exerted on the aeroplane is going to be equal in magnitude to the force exerted on the air. Now the first force exerted on the air is backward, and the force exerted on the aeroplane is forward. Both of these are in opposite direction. I didn't include the negative sign because we're only considering the magnitude, but both of these are going to be a Newton's third law pair, as I've said before as well. So we can actually just find the force exerted on the air, and we'll end up getting the force that is exerted on the aeroplane. And that's going to be mv minus mu divided by t. U is 0, initial velocity 0, so it cancels out. So we're going to get mv divided by t. mv we calculated before, 7.91 times 10 to the raised power of minus 3, divided by the time taken for this to happen is 0.2 seconds. And we get the answer as 0.039 newtons. So just to phrase it again, the change in momentum is this much, and it happened in a time of 0.2 seconds, and this is the force that is acting on the aeroplane. So that's going to be the end of this question, and now I'm going to show you the mark scheme and the examiner report.